Lukasz. I usually say I come from the internet since it's, usually I'm very far from where all the conferences are. And that includes also this particular event. I am here feeding back to the mic. You can find in all sorts of places online. You can find me on GitHub and Mastodon as ambv. I can be emailed. Sometimes I even get the emails and respond. So feel free to contact me. So yeah, as I say, like I come from a faraway place called Poznań in Poland. I actually tried to see whether I did like 10,000 kilometers on the way here. Turns out no, but close. But it is still the closest I've ever been to the equator. Only 6 kilometers, like, south, and I would be at the equator. That beats my previous record on Oahu, Hawaii by 4 times. So yeah, personal records. And even though I'm so far away from where I live, some things actually tend to be universal. So this is the city I left, and this is the city I arrived at. So, like some things just never change. But honestly, there are things that I want to really see here, some sightseeing that I'm going to do after the conference. So wonderful place. I'm very happy for the invitation, for the opportunity. But now let's talk about a colder place, Birmingham, England. Back in 2009, I went here to my first ever international conference as an attendee, right? 2009, this place actually does not exist anymore. It was demolished and replaced by a bigger one. Like everybody does this, I guess. And at this conference, like I was really shy. It was the first time ever speaking to people in English because they were not understanding Polish. They were, actually English, the British English kind. So, I was kind of shy, didn't talk much to the people I met and I knew from all sorts of places online. So, like, my recommendation to you would be to not be shy and just to talk because it's fine, we're just regular people. But then I was kind of shy for a while. And then I saw this. There was a person next to me at a presentation typing into Vim. But what was happening was not necessarily just regular editing that I knew with, cursors going up and down, but just text just kept appearing and the crosshair just kept getting, moving in unpredictable places, and text essentially was formed as if the person that I was I was next to was talking to the editor. And I was fascinated by this. I knew about Vim before, right? But I thought it was this sort of nerdy notepad that can maybe syntax highlight, but like this was nothing I have ever seen before. This is not actual footage of that thing in 2009. There were no typed text. And definitely you didn't have to replace the class-based typed text with the function-based one because you want to use a key that has a space in it. So like that was not what Honza Kral was doing at the time, but I was fascinated by how quickly he actually used his editor to code. So I started pestering him about Vim over the entire conference, for which he is still making me a hard time today, like 15 years later, saying like, I remember this like UUID, you were so annoying with those like, how do you do that? How do you do that? But that's what you get when you are really fascinated by a thing and you want to learn something. So Vim, that made my visit to EuroPython 2009 in Birmingham worth it on its own. But there were more things there. For example, I learned about, I'm going the wrong way now. The clicker does not like me. Let me see. Oh, okay. There was a lightning talk there by a person that I don't know who that was anymore. Like all videos online from Birmingham from 2009 are gone. So if you manage to find this, there's a bottle of single malt Scotch whiskey waiting for you. It's a core memory of mine. So if I can relive that lightning talk, I would be very happy. In this lightning talk that the person who gave it called How to Code Like a Supervillain, he enumerated all the dumb things that supervillains do in movies that ultimately cause them to lose to the main protagonist. Right? That there's a long list, but the main course there is that they don't use the most powerful weapon they have right away. Instead they just
do those long talks about why they are the way they are, and and they just give enough time to the hero to find a way to spoil the entire thing for the supervillain. So this guy said, like, no, you should just use your most powerful weapon right at the start. Don't leave any chance that the hero will prevail. And obviously for programming, there is a parallel there where he says, instead of just doing prints, instead of using a debugger, learn the debugger, use the debugger right away. Instead of just writing in Notepad or some other editor that you don't know, learn the editor, use it to your full advantage, and so on and so on. So I don't give justice to how he delivered this because it was both funny and kind of, awesome. But the point stood with me over the years, right? It was like, wow, like obviously we have all those awesome tools. And even though we know about them and we know about best practices for using them, somehow very often we do print debugging, right? And sometimes we really don't write tests, and sometimes, and so on and so on. So I started thinking, why do we do this? And to the best of my kind of ability, I figured out that it is because of friction. Friction happens when you're trying to do something, but it fights back. It is not very easy to do, so you have to actually put enough force to make it move, like to put it in motion. So obviously with physics, the problem is that there are irregularities on the surface and in the object, so they interlock, and you need to actually fight this static friction to actually get the thing in motion. And even then, there's kinetic friction that fights you all the way forever. But I'm not here to talk about physics. I'm here to talk about friction in our lives as software developers. So, are there any parallels there? Like, are there any things that because of friction we don't do that we should be doing? Oh yeah, there's a lot. Let's start with continuous integration. Now, we live in the future. Like, it is easier than ever to set up GitHub Actions to make sure that your tests run and everything is green or red, depending on how lucky we are. But we still don't do this with our personal projects that we have because it takes a while to set up, and you have to understand YAML, and if you live in Norway and you said no, all those things are kind of weird with YAML and with continuous integration, so we sometimes avoid it. We even avoid writing tests, even though Poetry or PDM or whatever you're using to create your new project literally creates the test file for you. So you're able to just start writing the asserts. But writing the asserts is something else, feels different than writing the feature. So sometimes you're like, I'm going to write them later, and later becomes never. So, nah, not great, but this is what we do. Same with refactoring. Once you don't have tests, and then you actually have to change something fundamentally, you're afraid to do it, because now we don't really know, is this going to still be the same? And if you have test coverage, that sometimes doesn't help you either, because the tests are so detailed that if you refactor, you're going to have to change tests. So do you actually know if it still works? Well, we don't know. So we avoid refactoring. We're like, yeah, we're going to do it in the fascinating version 2.0. Version 2.0 is going to be awesome. It's going to have all fixes. Sometime in the future, maybe never. We could maybe type annotate, and now we could refactor. But you're like, well, it's kind of ugly. I don't actually want to write all the static types. This is not why I'm using Python. Rah, rah, rah. So we don't do this. And we don't really like when MyPy is pestering us or pylons, in VS Code. So we avoid that as well. And finally, once stuff gets slow, which in Python is common, we don't really know how to set up the benchmarks. And if we do, they take a long time to execute so that they are reproducible. Because the laptop that I'm using also runs Slack and Chrome. So obviously, all the benchmarks are kind of random anyway. So we don't do too much of that. And profiling, well, forget it, right? This is something that is so much knowledge that you need to now internalize, that we often just avoid the entire thing. So there is so much of things that we could be doing, but we're not particularly doing. For example, a great way to avoid performance issues in Python is to use Async IO. And you would say, well, awesome, but it is so alien to me. There's some asyncs and there's awaits, and all the frameworks are different now. I learned Django, I learned different things. So now I would have to relearn this. So maybe later, maybe another project later on in my career. So what about starting new side projects? Sometimes you do, but if you did this enough times, you're like, I know how it's gonna go. It's not gonna be a 2-evening project. There's gonna be a thing that I'm gonna do to fix the thing, and then another thing that I have to do first. And suddenly you find yourself 4 layers below what you try to accomplish, and you don't even remember why you're doing this anymore. So no, let's not start new projects. Let's contribute to existing projects. But the last time you did this, the person that is the maintainer said like, hey, I don't like your indentation here. I don't like your comments. Like, you should actually write a different comment here. Or maybe they're like, oh, the feature that you want to add, I actually want to add it too, but not like this. So we're not going to have it now. We're going to have it later. So you learn that actually interacting with people, friction, it is annoying. So we avoid this. Let's just use mature projects. Let's use mature tools. But then you open the documentation and it's long and tedious and whatnot. So you're like, well, this is not what I understand as Pythonic. This is not what I understand as, easy to use. So we avoid this. So there's so many examples of what we can do, but we don't because it's friction. So I should really name this talk friction. It's bad, right? Kind of obvious, but there's so many things that we avoid doing. And it is a little sad, honestly, right? Because it makes us kind of avoid doing the thing that we really want to do. But we just kind of anticipate the problem. We anticipate that it's not going to be as easy as we wanted. So we're just taking shortcuts. We procrastinate, and it's a little sad. And it makes us sad internally as well, right? Even if we do code, sometimes we focus more on the writability of it. Like, let's just push it out as fast as we can, not thinking about the readability 6 months, 12 months, 24 months from now. But mostly the psychological part of it is that it makes us miserable. And it contributes to burnout, because if you face the friction enough times and you don't learn how to handle this effectively, at some point you're going to get discouraged enough that you're going to just say, this is not worth it. I don't like this anymore. Like, this is not bringing me joy anymore. So is there some magic way to fix this? Is there a magic way to just make the friction go away? Well, no. The thing that you have to do is just to power through it. This is my favorite song from my favorite album by the 9 Inch Nails. It's called The Way Out Is Through. And it's not just an awesome title for a track, but it's also profound if you think about this. That is really, if you do something enough, if you persevere, like, you're gonna actually reach the end at some point, right? If you learn an instrument, like the guitar or piano, learn to sing, right? Like, actually the repetition, the doing of the thing makes you better at it in time. And this practice also translates to what we are doing as software developers, right? So this is essentially this really kind of expected, but profound truth that as long as you keep at it, it's gonna get better. At some point, it does get better. So yeah, like, learning by doing is the best way to do this. So I personally just start a ton of small projects that I never intend to publish on GitHub or whatnot, just so that I have fun with some particular thing that I want to learn just for a while. But you're thinking, Lukasz, cool, but if this is just a throwaway project that you will never put on GitHub, like, what about the quality of it? And I care about quality a lot. In fact, this is an icon from the cover of my favorite book ever. It's the Zen and the Art of Motorcycle Maintenance by Robert M. Pirsig. I reread it every few years, and I really find it, compelling every time. And it does focus on quality a lot. I highly recommend the book. But one of the things it also says is that quality comes from quantity. And it's a little bit surprising, but you don't have to believe me. At the University of Florida, there was an experiment some time ago where the students of beginning photography were split into 2 groups. One group was the quality group, and the other group was the quantity group. And at the end of the semester, they were graded. The quantity group was graded purely on how many photos they took. And the quality group was graded on one single photo that was their best photo that they submitted at the end of the semester. And what people learned from this experiment was that not only did the quantity group learn much more, but in the end, their photos were much better. They had much higher quality than the ones of the group that did not have the same experience, did not push through so hard. So this is essentially the thing. Like, the more you do it, the better it's gonna get. There's no way around this. So, you know, like, we're thinking, throwaway projects, cool, I'm gonna start some and I'm gonna do this feature, I'm gonna learn Django, I'm gonna learn Async IO with this and whatnot and whatnot. But I wanted to also focus on this maybe underappreciated part of our work, which is our tooling. If you are going to spend the next 30 years doing the deed, right? Programming, being the software developer, being a data scientist. Like, doesn't it make sense to spend a month or two really learning that editor, really learning to debug, really learning how those things work a layer below, 2 layers below, so that you actually have a deeper understanding of them? This will pay dividends really quickly because we are going to spend so much time using those tools going forward. So the Vim thing that I learned in 2009, still paying dividends now, even though I no longer use Vim, I use VS Code, but it's still making me express myself faster than I could do otherwise. So I highly recommend you to also just think about, like, is this the tool I'm going to want to use in the next 5 years? And if so, like, spend some more time just playing with that, not trying to solve a particular issue and create a particular project, but really learn just what that project is about, what that editor is about, and how it works underneath. Maybe create your own extension, maybe do something with it that it makes you understand what's happening a little better. So this also extends to the equipment we have, right? Like the laptop that I have standing here, like, it's 2 years old, but at the time I bought it, like, it was the most expensive piece of equipment I've ever purchased. Like, it was like 64 gigs of RAM. Like, so, like, people kept asking me, like, Lukasz, like, are you actually gonna run entire clouds on this? Like, why do you need 64 gigs? Like, what is this? And I really didn't have a good answer for them at the time. I just knew I am too poor to switch laptops every year, so I'm going to spend like 5 or 6 years or 7 years with this one. So it better be the best it can be today, because I'm just going to need the performance later on. But I quickly found out that, like, as a CPython developer in residence, I build Python daily, like 10, maybe 50 times sometimes. I review a lot of diffs, so, you know, kind of every now and again, I would have to really just build it, try it out, maybe make a fix and publish it back to the PR. So once I did this a lot, I started thinking, well, am I wearing out the SSD too quickly by creating a gazillion files, running tests, and then deleting them, and then creating the gazillion files again and running tests and deleting them, switching branches, and so on and so on. So what I did instead, I put all of this in memory. And, you know, obviously, if you cross the laptop and the memory goes away, like, you lose all your information. So, like, is that really sensible? No. But what I did is I put the Git repository, like the .git folder, like you could call it like this, on the drive. So that's safe. Whenever you commit, this is safe. But the work tree, so the actual files that are used when you're building and you're running tests and whatnot, this lives in memory. This allows me to actually have multiple branches open at the same time, makes builds much faster, and so on and so on. So because I knew I'm going to be doing this all the time, I actually created a script that allowed me to just say RAM disk. And it just, you know, spends a few seconds, done, and says you can now change directory to your checkout of Python, which is now fully in memory, and it's going to take you just a few seconds to build. And in fact, I can build it. I can just say build py, which is another shortcut that I wrote, because there's plenty of things that as a CPython developer residence I want to have in my build Python. So yeah, it's going to do like the configure, it's going to do make. Now it doesn't say what it's doing, but it's freezing the standard libraries that are required for the interpreter to stand up to start up. So that actually part like takes like easily half of the build. So the entire build takes 18 seconds. Maybe not that quick, could be faster, but it's fully reproducible and I can do this so many times per day. It just makes sense for me to invest time in this because it's just simply so common that I'm doing this. So I recommend you also to observe what are the things that you're wasting time on all of the time. Since the quickest way to go about something is to not do it. So if you have to do something manually, but you can automate it, you absolutely should, right? So obviously, I'm just putting a lot of kind of pressure on you now to just improve your own situation. But like, come on, dude, you're literally hired to make Python better. So like, you know, is Python getting better for us? Yes, it is. Like, hopefully, the newer the version of Python that you're going to be using, the more you're going to see that it actually is constructed in ways that now are more helpful to you to achieve your goals. And the easiest example for me to demonstrate this is the error messages that we emit when there's an exception raised. So not long ago in a Python version very dear to my heart, when you actually caused an error and there was an attribute error, Python just told you, okay, this attribute does not exist. Okay, helpful enough. But now, Python will also tell you, did you mean a different attribute that actually exists on that same object? Which is pretty amazing. Uses the Levenshtein distance, actually works also for module bodies and also works on variables. So if you misspell a variable name, all is good. It can actually suggest you a better name. It won't always suggest you the best name. Levenshtein distance is not magic. It's not GPT, but it's good enough to be actually helpful. All right, so if you don't switch from Python to the other programming languages, you might say like, what is this? Do people really forget colons? But if you do switch between multiple languages and the other one that you're using does not use colons to end, you know, blocks, well, this is essentially a very common issue. And if you're just starting to program, like, obviously it's a problem that you're gonna have like every now and again. So just saying invalid syntax, not really helpful. Saying expected a colon here, super helpful. And this is an entire array of things that Python does now. So for example, if you forgot to put double equals, just put a single one, Python will now tell you like, maybe this is what you expected, and so on and so on. Python expects indentation, right? Like, it is significant for us to actually you know, kind of build blocks for ifs, for loops, for functions, for classes, and so on and so on. Sometimes it's easy to see where you pasted your code and what the alignment should be, since, you know, like the if is right there, like the line above. But sometimes the if condition can be several lines long, sometimes the function signature can be complex, so it might not be very easy to see, like, where am I supposed to align the code? Now Python will tell you, like, you are trying to indent with this thing right there. So if your code is long, this is going to be really helpful. Brings me to, what if your data structure is long? So in that case, sometimes it's really hard to notice the issue. There's a problem, but like, we don't quite see where it is. Like here, there's syntax highlighting, maybe you already noticed. But if you didn't, Python 3.8 would unhelpfully tell you that the syntax error is in a line that is perfectly fine. Yeah, so now with Python 3.10, it'll actually improve and say, actually, the error is here because perhaps you forgot a comma. And that's indeed what happened, and we can move on with our lives much faster. So those things are not just for beginners. Those are just, you know, kind of improvements that make you, you know, go on with your life quicker. Like, you don't have to be now the Sherlock Holmes looking for, like, where is the comma missing. Python will help you out with this much faster. You know, with unclosed brackets, that's even funnier because, you know, you're saying like, come on, like, who forgets to close their list when they open a list? But what if you have kind of a nested data structure? So there's a couple of lists. Maybe there's a dictionary with a list, with another dictionary. In this case, it is not uncommon to forget one particular closing bracket. So now Python will actually tell you, this is the list that you're trying to match, which makes stuff much faster. And if you have an attribute error like this, where non-type object has no attribute parent, in this particular place, there's 3 places that might have caused this attribute error in this long path. So Python 3.10 will actually highlight this for you, saying element.parent raise the exception, meaning element is none. So that is much faster for you to figure out, like, oh, okay, I see. And if it was another one, like it would say you siblings of 1 dot parent caused the exception, so siblings of 0 is none. and so on and so on. So there's plenty of improvements just in error messages alone, but obviously it would be boring to just tell you about like, hey, if you ever have exceptions, they're gonna have nicer messages. So let's talk about something else. Let's start with something maybe not that controversial, but more controversial than you might think. Nowadays, everybody loves f-strings, and they're like, of course, like f-strings are like a core feature of Python. But when they were introduced in Python 3.6, there were many people saying, do we really need another way to format strings? There's already % formatting, and there's already dot format on strings, and there's already template formatting in the string module in the standard library. So they really need just another one, like this is weird. But it quickly turned out that when Python 3.6 was introduced, this was the most popular feature. People started using this. But what you might not know is that f-strings kept evolving. Like with new releases of Python, they learned to do new things. So we started really kind of in a now what seems a very natural world where the time is now, and when you put this in braces, the variable now will be used and replaced, all is good. We can actually put any arbitrary expression there, so we can do math, we can do some more complex computations in our strings. We can also now, that was added in 3.8, end our brace blocks with equals, which will also output the left side of the equals sign in the brace, which is very helpful for debugging, like terminal size, columns equals, lines equals. But the newest line that is coming in 3.12 that you might not see if you're in the back allows us now to reuse the same quote sign from the entire f-string inside the braces. If you see, like we're using the double quotes here, but the entire string is double quotes. That is a little weird, but it's perfectly unambiguous because we know that once we enter the brace, we need to leave the brace before we can finish the string. So now the parser can handle this perfectly fine. This is now part of the grammar of Python. So let's talk about something a little more controversial then. Controversial enough, even though it's a small feature, that it made the creator of Python leave his post as the benevolent dictator for life. Like, the friction of getting this change into Python was big enough for even him to call quits. So nobody is actually, immune to this sort of problem. And to talk to you about assignment expressions, like, let me show you one of those like weird like side projects that I might do, like, sometimes after hours. So you already know I like 9 Inch Nails, and this is genius.com, my favorite lyrics website that not only just has lyrics, but also allows people to edit them and submit the edits, which is godsend for me because I hate it when my favorite lyrics are misspelled on some website. So I can do this here, and I can even, have some comments on a particular line, like saying like, oh, this actually references this other thing. If you're like an ultra fan of something, like, this is pretty cool. So obviously we wouldn't be talking about this if there was no API and a client in Python to access the lyrics. So you can download a lyric of a song, or all songs from an album, or all albums of a particular artist. And this can be used as a library, but also as a tool, which I'm doing right here. Just download the thing to JSON. So I'm doing this, and then with some basic JSON loads, I can load the lyrics and display them. And they kind of look like what they should be, but they have also some unwanted additions. What is this? 14 contributors, the way that was through lyrics. Like, no, Trent Reznor did not sing that now. And there's like one embed at the very end. Like, if you look back at the website, like, oh, this is just badly, scraped HTML, like that is right there. So you look, the new song page is a work in progress. Like, oh, apparently they just broke their API. So we can just use Python to clean this up, right? It's pretty easy. You just use some regular expressions. And by the way, if you just flinched at the regular expressions, like, yeah, like they come up all the time. It's worth to just spend some time on them. Nowadays, like there's websites where you can just put regular expressions in and learn about them. So learning them interactively is pretty cool. So here we're using those 2 regular expressions with assignment expressions, which saves us a few lines and makes reading this much more natural. But there's even a third one right there where we construct a regular expression on the fly based on the title of the song. So, you know, long story short, this actually makes the lyrics fine now. And we use assignment expressions. So are assignment expressions now overused by people? Like this was the main kind of critique of the addition at the time of Python 3.8. Like, you know, people are going to start using the walrus operators or colon equals all the time now. This is terrible. This looks like Pascal. Like, this is going to be abused. It's not. In fact, now it's only used in very limited places, but when it is, it turns our code that was sort of fine before into code that is more delightful to look at. So that's pretty cool. And there's more examples of gradual improvements that we have in Python. Like, for example, pattern matching. The biggest feature of Python 3.10, even though I have my own favorite. You know, so to talk about pattern matching, let's obviously talk about something totally different. So this is a thing that I wrote just to learn about Textual. Textual is this framework that lets you make fancy, you know, UIs in text mode for the terminal. So I wanted to learn this. So I wrote this simple text game where you can crawl a dungeon. There's an inventory that you can show by, you know, either pressing the I key or clicking the show inventory button right there. And then, you know, you're going to have a nice animation that shows you the inventory tree, and you can click on an item, the inventory tree, and that will cause the item to be equipped by the player, right? So if you're intrigued, Textual is on PyPI, like, you know, it is actually pretty cool. So I highly recommend it. We're not going to actually have a tutorial of Textual right now. We're going to just focus on a tiny piece of it, right? And that tiny piece of it is what happens with this inventory tree. So before we get there, like the inventory that we have, the data is actually stored in just a data class that just has a list of items. Nothing really fancy there, right? And every item for the purpose of this talk is as simple as just a data class with a single attribute, which is its name. That's enough for us. The game object holds the inventory and a bunch of other things that, you know, didn't fit on the slide. So that's all good. So what happens if we actually open an inventory? What happens is we are going to we'll have a callback called for us, and that callback will get the node, the tree node, from the Textual framework and tell us, okay, you react to it. So we have to implement the callback. So I implemented it like this, right? Like you're going to get this node. That's the only argument really that we're getting because it's a method on a bigger object there that we don't care about right now. So the tree node comes either with an inventory object in it or with an item in it. So we obviously have to differentiate between what did we get. So we do an is-instance check. If it's an inventory, we do a bunch of things. If it's an item, we just equip it on the player. But if it's an inventory, there's actually two things that are happening here. If the node was already loaded, meaning we already saw this data object, we can just display it like right away. We can just toggle the nice animation. This is why we're using await. It's animating. But if it wasn't loaded yet, we need to load it right now. So we're enumerating over the items and adding each node so that the inventory actually enumerates. It is visible on the screen. So this is perfectly serviceable. This is valid Python code. This is fine. But now with pattern matching, we can express it a little differently. We can say we want to match the node, and there's three cases that we really care about. And this reads weird if you've never seen pattern matching before, because we're not actually calling tree nodes. We're not creating inventory objects. What we're saying in case is that, we're going to match if the node is a tree node which contains a data field on it that happens to be as an instance of inventory. And similarly, we need the tree node to have a loaded field on it that happens to be true. And in this case, let's do this. And if there is an inventory inside the field called data, but the loaded field says false, in that case, let's do something else. And I'm also showing that you can assign names to sub patterns here in the cases so that we can just use it directly in our code right there. And finally, the third case, if the tree node just holds an item instance, then let's just set it on the user, right, on the player. So if you look at both, you know, like they don't really, they still look like they do the same thing. Like they're not really that different. but the match is both shorter and more regular, right? There are no kind of inner if-elses that you have to think about. So the kind of, complexity, like the computational complexity of it is flatter to me. And I also think personally that it changes the quality of my programming from thinking procedurally, of literally just calling a bunch of things on those ifs and elses and seeing what's going to happen, to something that is more, declarative. That I'm saying, I want a tree node that is like this one. And Python just matches one for me right there, right then. So pretty cool feature. I highly recommend you to just play with it like in any case. We're going to see this later on in the talk again. So finally, Async IO task groups, like I love Async IO. I made a bunch of videos on it. I made probably like 50 talks about Async IO internally and externally, in places that I worked at and, at conferences. I love Async IO. Somehow it works with Eastern European minds for some reason. I don't know. Like, if you disagree, then, kind of, it just allows us to just put async everywhere, which is cool. Like now, like what it's doing is it allows us to make things happen concurrently within one thread, so that if you have a lot of I/O, if you do a lot of things with networking or whatnot, the laptop is still here, the slides are not, then we can do them in a way that appears to happen at the same time. So we can actually make async def, an async function that downloads multiple files. And in this very easy form, using the functions that we defined on the previous slide, we're going to get the first file first, then the second file after the first one already downloaded, and after the second one finished, only then we're going to get the third file. But I told you, like, well, the magic of it is that we can do things at the same time. So we can actually use the magic of Async IO gather and actually schedule those three things to happen at the same time. And this is kind of beautiful in the way how it looks. The problem with it, though, is that if things go wrong, and there can be multiple things that go wrong, one file might be a 404, might not exist. There can be a timeout downloading another one, and the third one might not be even needed if those other two failed. So if we have many things wrong at the same time, recovering from this and even discovering what exactly went wrong is pretty complex with this easy expression, with this easy form of async IO.gather. So what I usually recommended to users of Python 3.10 and before was for users to use async IO.wait, which works perfectly fine. But as you can see, this is a much more complicated kind of construct right now. We have to create some tasks list and, append all the tasks to it, and then we have to wait, and later on, that I didn't put on the slide, like sift through what was done and what is still pending, and so on and so on. It's very easy to get error handling wrong in this case. So in Python 3.11, what we added was task groups that now allow you to just say, we have a group of tasks. We create tasks inside this task group of the three things that we want to do, and then there's not even a single await. Why not? Because the task group async with will only ever leave, right, the block when either all of the tasks that we declared finished, or if any of them failed, in which case we're going to cancel all of the others. So we will never leave any task stranding. This is actually the best way to make sure that all errors are handled. And better yet, we're not going to really be diving into this, but we can now handle all of the possible exceptions that happened using except star and exception groups at the same time. So if you have many things that can happen, many things can go wrong, and now we can handle all of them at the same time. So pretty cool. Actually, I'm very happy about those improvements in Python. I would like you to be able to use them. But the only way for you to be able to use the new features is for you to use the newer versions of Python. So not all improvements that we're making are even up to code. Back in the 3.8 times, we released Python irregularly. Sometimes it happened every 18 months, that was the theory, but sometimes it was closer to 24. Whatever works for people. It was entirely unpredictable. And it also made the releases pretty big. They had many features, so it was hard to upgrade from one release to another. So I proposed, like, how about we change this? And this is a nice graph that I, drew at the time of PEP 602. Like, we can do releases annually. so that now they're going to appear in October every year. So people can expect this, Linux distributions can expect this, so they will be packaging newer versions of Python than they used to, like everybody will win. And somehow I convinced people to do this, so we adopted this, starting with Python 3.9. Obviously, the real schedule doesn't look exactly like this. There's some movement here and there. Sometimes we release a version and it actually had a bug and we have to fix the regression very quickly because it was serious. Sometimes we just release a version and then there's a security vulnerability discovered, so we have to follow up like very shortly after with another release. So obviously, life is more complicated. But the broad strokes of what you're seeing here are still true. So every October, you're gonna get a new version of Python. So currently, we are here, right? Like the newest version of Python available right now is Python 3.11, and we are working on Python 3.12. We just released Python 3.12 beta 2 a few days back. So my recommendation to you would be to just start new projects with 3.11 already, because as you can see, 3.9 and 3.10 are already in this wide security-only releases period, which means they're still supported, but we don't fix regular bugs in them anymore, only security bugs. So 3.11 is the one that we support fully right now, shortly to be followed with Python 3.12. So we could talk more about like other features of Python that I like. There's sadly no time. Like exception groups, I just showed you on a single slide. It's there. It's worth learning about. I have an entire talk about this. Notes and exceptions make for much nicer designing of exceptions. Variadic generics, data class transforms, all of those are already available in 3.11. And then 3.12 makes performance even nicer. 3.11 is already very fast. 3.12 is faster than this. There's even better error messages there. And there's the perf profiler support. So perf is a tool on Linux that allows you to profile your C and C++ programs. So the big boys and the big girls like writing their low-level programs, they would use perf. But the problem with perf was that it would show the Python frames, the functions that you're calling inside Python, in a very convoluted manner. It would show the C API, kind of version of what is happening, which would make it very hard to see which particular Python functions that you wrote were executed and how long they took. So now with 3.12, you can actually use perf and it will show you the Python functions actually ride with the C functions that you're calling. So the entire face of the program is now visible to you. So super cool. So pretty kind of promising for the evolution of the language. I would recommend you to just, check this out. But I wanted to finish with maybe something unexpected, which is that friction, even though it's so bad, and I spent like the last 40 minutes talking about it, is not always bad. Sometimes we actually expect it. Sometimes we actually want it, because otherwise, it would be pretty dangerous to go and, do things. So in real life, obviously, kind of friction is what makes me able to walk here and not slide. But in programming, and in Python in particular, there are plenty of examples where friction is designed right into the language. It's kind of weird to hear, but if I give you a few examples, hopefully you agree that, we have significant indentation. You cannot indent things as you wish, right? We actually tell you like, no, this is the one right way to do this. You'll do it, or we're gonna throw syntax errors at you. And obviously with Python, as Python people here, we kind of know this and we accept this, and we even enjoy what it gives us, because this friction allows us to read programs by other people as if we wrote them, because they're formatted more or less the same. And if you're using some other formatter, then maybe they even look more like your own code. So, this actual friction is useful for us to read code later. Having to import sys is also like a friction roadblock. It's just a small, tiny name. Who is using sys for anything else than the standard library? So we could just put it in built-ins, right? But we never did. Of the 30 years that Python has, we never thought about putting sys in the built-ins. And the reason why is that it would be special. It would not be kind of, consistent with what we want from the language. We want to show users right at the start that, you should put your code in modules and you should just import them from other modules. This is the right way to structure your coding. So this is why we have this friction of import sys. And we also have the friction of having to type self all the time. If you think about this, is like there are languages that don't have this. You know, it is perfectly possible to create definitions of classes that don't need self dot everywhere, and you don't need to put self in the function signature. So why does Python insist on this? Well, because self dot makes it really obvious that you are accessing an attribute or a method of an object. And on the function signature, it makes it really obvious if it's a regular method or a class method or a static method. So we have this tiny bit of friction that you have every time you create a method in Python, just because it makes for a much easier reading of somebody else's code later on. And similarly, if you return things, there are plenty of languages that only use the last expression that just happened to be in the function to return whatever that expression returned. And you don't have to say return. It just happens. So why does Python force you to type all those characters? Well, because it is pretty common for people to make mistakes, and they just forgot to return it, or they didn't put a return on a particular path through the code. So actually forcing everybody to say return every time makes it much easier to discover when those things are happening. There's in fact one place that this still happens implicitly in Python. We're gonna talk about this in a minute. So obviously the await keyword is similar, like why don't Python figure out that the function that I'm calling is an async function? Why do we need await? Well, because await is also a place where global state on your program can change, because now the execution is suspended from your particular async function and other things are executed in the meantime while you're waiting for the file to download or something, right? So things in your global state might change. Variables might have different values now, the global dictionaries or whatnot might be different. So having await as a keyword that you have to put there makes it very easy to reason about oh, those are the places where my global state might change. And finally, type annotations also are friction, right? Yes, you have to put them. If you don't put them, it's less work, right? But if you do put them, what that gives you is better documentation. And if you can use a tool to automatically check whether they're correct, then they're going to find many issues in your programs. And I tried really hard not to talk about type annotations in this talk. But if you really want a talk that doesn't cover type annotations, you have the wrong guy. I really like type annotations a lot. So let me just give you a small example that is really recent, and I actually think kind of drives home why this thing is awesome. So there's just some entity class, doesn't matter what it does. The thing that matters is that we can create it from some UUID. And that UUID is a globally unique identifier. We can use the object from the built-in library inside the standard library called UUID. And therefore, we somehow create this entity. Cool. So if we get them from the database, what I wanted was for the user to either provide the UUID object, right, straight from the library, or just provide the underlying integer that the UUID is built on, or just provide the UUID string representation, which is this hexadecimal, letters and numbers and some dashes. And if the person actually specified the integer, we're going to do some magic to create the UUID object on the fly. So if we actually run a type checker on this, it'll be perfectly fine with this. But this is not what we wanted, since we also wanted the string, kind of case to be handled, but it's not. So why does the type checker not tell us that there's something is wrong? Because we didn't annotate the return value. If we did, then straight in VS Code, you don't even have to run any tool. You don't even have to try your program out. It'll tell you right away that, none cannot be assigned to type. It's a little weird of an error message, but it actually says that we have an implicit return of none at the very end of the function. Oh, so we need to fix this so that we don't have this. Okay, so we can do this, but we can do even better. We can use pattern matching and just say, okay, let's match on ID. If it's an instance of UUID, let's do this. If it's an instance of integer, let's do this. And here, even the ID has squiggles on it. Why? Because the type checker says, oh, there are cases that you didn't handle. So it will actually help us to make exhaustive case matching right there, and it will tell you which one is missing, which is beautiful. This is how Rust does error handling. Rust doesn't have exceptions because it has this. It has this, exhaustive pattern matching that allows you to always handle the positive case and the error case. If you forget about the error case, the compiler in Rust will remind you that like, oh, no, you need to come back and also handle this case. So now in Python, you can have the same thing if you're using pattern matching and function annotations. So, hopefully this was a little cooler than the typical type of annotations you see every time. I am the only thing close, like holding you from the breakfast. So let me just, show you friction again. And now I'm like, what should I call this talk again? Friction is bad, friction is good. Like, no, actually it's more complicated than that. But the one thing that I'm gonna be remembering from this talk is that the way out is through. So thank you very much. That was my talk. Like, I'm happy to answer questions after.